Oh, good morning or good afternoon, everyone. We're just about to get started here. I see that I'm watching the numbers, and I know people are rolling in. The participant number is shooting up. I don't know, Betsy, if you are on the call. I know you're having some technical difficulties there. I'm not sure if you wanted to say a few words to kick us off, or if I should just get going. I'm not sure I see her there. All right. Well, I'm going to assume that unfortunately Betsy's technical difficulties have continued. So what we'll do is, in the interest of time, we'll get started. And if Betsy's able to join us, we'll give her some time to say a few words at the end. So let's dive right in. As I said, good morning, good afternoon, depending on where you are. My name's Chris North. For those of you who were on the webinar last week, I'm joined by Samaya Siddiqui, and we are going to take you through part 2 of our the webinar series workshop on using GIS from data gathering to storytelling. Today, we're going to be doing some more of the analytical stuff. We're going to pick up where we left off. Let's carry on. Just a reminder to everyone as we go through some of the housekeeping items. We are recording our session. I'm assuming that Mingzi, you have started. Mingzi is our host. I'm assuming that Mingzi, you started the recording, because I'm not sure I've got. Yes, we have. We started the recording, so that's great. So we are recording today's session. We will be sharing the links to that. I saw some of the questions come in that some of you were looking for the links to the recording for session 1. We are going to make all those links available in some emails that we'll be sending out to everyone. So if you didn't get the email, do let us know, and we'll get that link out to you. Again, just keeping with the housekeeping, do remember that everyone's microphone is muted. So Samaya and I, hopefully you can hear us, but we cannot hear you. So please do use the Q&A, the best way to get a hold of us. Down in the corner of your WebEx window, you should see the option to open up your chat and open up your Q&A. Do send us a Q&A. Make sure you send it to all panelists. That way, myself, Samaya, our host Mingzi, we will all see it, and we'll make sure that your questions that you send in don't get missed. All right. Without further ado, let's dive right in. So today, this is workshop number 2. We did workshop number 1 back on the 20th, where we introduced you to our ArcGIS Online GIS environment. Samaya took us through finding and using data sets. We covered how we can make maps, how we can change the symbology of those maps, how we can publish some applications. You recall we went through a really neat little exercise where we went from Excel spreadsheet and some polygons to a map showing the prevalence of diabetes in Winnipeg. Today in workshop 2, we're going to go a little bit further. We're going to dive a little deeper into some of the analytical capabilities of GIS. What we were doing last week was really managing the data and making a map. Today we're going to take that data, some of the existing data that we worked with last week. We're also going to introduce some new data sets to you as well. And we're also going to learn what we're going to do is learn how GIS can actually perform analysis. Sure, we can look at a map, we can see patterns on the map that we visualize, but how do we quantify those patterns? How do we look at the statistical significance of those patterns and dive into some of the other things that we really understand and start to gain those insights? Just looking ahead, next week on February 3rd, we're going to be looking at some of the other applications that are available to you to extend what you do with ArcGIS Online. So we're going to look at maps for Office, we're going to look at creating dashboards, we're going to look at creating and publishing story maps. In other words, we're going to look at how we take the stuff that we do inside of ArcGIS Online, and now how do we leverage it in Excel, in Power BI? How do we leverage it in a dashboard? How do we leverage it in a story map? That's what we're planning for next week. So for those who might be new and weren't able to make it last week, just joining us, a very quick recap of what we covered last week. You'll recall that we positioned GIS really not as one thing, but as a system, if you like, a system of systems. And a GIS really is about a system of record for measuring, storing information. It's a system of insight for doing analysis and exploring, and it's a system engagement for communicating and getting your GIS into other systems. Really, and what we talked about last week was really all about that system of record. Let's create the data. Let's manage the data. Let's make a map. Today is all about the system of insight. Let's explore the data. Let's do some analysis. And really next week is all about that system of engagement. Now moreover than just the three systems, we also talked about how GIS is really a framework. It's a workflow takes us from simply measuring and storing data all the way through visualization, analysis, planning, decision making, and then indeed taking action. Right? We also covered the importance of geography, how geography is that universal locator. We can use geography, we can use location to bring together data sets that aren't otherwise related. So we can bring together, and you're going to really see that in spades today, how we can bring together the pattern we see in where we've got our community centers located and the patterns that we see in things like the prevalence of diabetes and so on. We're really how we can use geography to bring those two things together. We also looked at just positioning where we're working in the product stack. I mean, GIS is a lot of things. There's professional desktop GIS software, there's enterprise GIS, there's developer GIS called platform, but we're working in that ArcGIS Online environment. And the last thing I wanted to recap, because it's kind of leads us into what we want to do today, is we looked at some of the history of spatial analysis and the role that geography has historically played in understanding health. And the one thing I did want to remind everyone is the first law of geography from Dr. Walter Tobler, which basically says that everything is related to everything else, but near things are more related than distant things. And that's really fundamentally what we're going to talk about today. Because what we want to talk about today is spatial analysis tools that are available to you in your ArcGIS Online. So what are these things? Well, we're going to show you a whole bunch of tools today that allow you to do deep geographic and scientific analysis of the geographic phenomena that exists in your data. All the tools we show you today exist in the cloud. They allow you to discover relationships and patterns and trends in your location-based data. They also allow you to apply location to data that otherwise, to begin with, doesn't have location information. We're going to look at a common analysis workflow that allow you to go from sort of very simple spatial data right through to working with these tools. Now, one of the things we do want to talk a little bit about is what do you require to use these tools? And as we kind of alluded to, at the end of next week, when we're finished the workshop, we're going to present all of you with some credentials that will allow you to have your own ArcGIS Online subscription for you to try some of these tools in kind of a sandbox that we're going to make available to you. So you're going to need the ArcGIS Online subscription, which we're going to provide to you in the sandbox. You're going to need a user identity, which that's basically what we'll be providing you. You will need some credits. Now, credits are something that everybody gets really wigged out about. They sort of understand it. They think of credits as being a cost associated with this. Credits are a budgeting tool. As you can imagine, some of these things that we're going to show you today are very powerful analytical tools. Some of them rely on third-party data, like enrichment, like the networking stuff relies on data from here and other partners. The bulk geocoding that we're going to be looking at in some of these things today requires data from some of our partners as well. And in order to manage all that and for you to manage all that within the context of your organizations, we have this notion of credits. Just think of credits as kind of your monopoly money for the GIS so that you can manage how much people can do. You also don't want people doing too much. You don't want people saying, oh, I think it's a great idea. I'm going to take every address in Canada and geocode it. And several hours later, when you've bogged down all the servers, you realize that probably wasn't such a good idea. So think of credits as a managing tool. And when the time comes, we'll give you some information on how to work with that. But really, we'll show you today how to look at credits, but it's not something we really want you to worry about in this context. Now, we're going to show you the analysis tools today in the context of working inside of ArcGIS Online. So fire up a browser, log into ArcGIS Online, start doing some GIS. But these same tools that we're going to show you today are not just available inside the browser. Yes, they can be used in the map viewer, and that's where we're going to spend most of our time today. But they can also be used inside the desktop tools. They can also be used in some of those applications. Remember, Samaya showed us last week how you can take a map and then publish an application. You can take some of those applications, and you can actually put some analytical tools inside of those tools, inside of those applications, so that you can give a little bit of analytical capabilities to some of your downstream users, some really interesting things that you can do. For those of you who are interested in data science, well, you can use our analytical tools inside of Jupyter notebooks. You can use these tools inside of Python environments. So you can create a Jupyter notebook. In fact, we host Jupyter notebooks inside of ArcGIS Online, and you can create a notebook with Python script in it and call other open source Python libraries and mix and match your Esri GIS with your other open source data libraries and tools and so on. Also in the desktop environment, you can blend our spatial analysis tools from ArcGIS with R. We have a bridge for the R environment so that you can pass tools and analysis back and forth between the Esri desktop GIS and the R package as well. And you can use these tools in JavaScript and in creating your own applications. So these tools are available everywhere, these tools that we're about to show you. So let's quickly go through the workflow. It's a very simple workflow. The first thing we always want to do is define our purpose. What is it that we are trying to do? What question are we trying to answer here? And as Samaya goes through the analysis today, and I show you where some of the toolboxes are, we'll tell you the questions that we are trying to answer. Now, of course, we're going to be using some fictional scenarios here, some fictional data sets and whatnot, because we're really just trying to teach you where the tools are and how they use them. You, as the public health professional, you will take these tools, you will define your own purpose, you will ask your own questions, and hopefully you'll be able to use some of these tools to answer those. The reason we started with the preparation of data last week is, well, obviously you can't do any analysis unless you've got your data prepared. Once you have that data prepared, and that was everything we did last week, you can then add that data to your map. And now that data is there, you're ready to work with it. Once you have that data there inside the map, it's simply a matter of running the tools. Set the environment, set the parameters, what fields do you want to use, what scale do you want to use, what characteristics do you want to use, how do you want to filter the data, and hit the magic run button. The GIS system will go chew away through its processes, and it will display the results for you on the map. Very, very simple. So a little more detail on what we do at each of these steps. Well, it's really simple. We can ask a question. What's nearby? What are the patterns that we see? What's the best location for something like a flu shot clinic? Or if I want to look at the best location for a community center, or what's my capacity in my hospital? These are the kinds of questions we can ask. Assembling the data, again, we did all that last week. We built our data sets up. Many of these tools we show you don't just work with GIS data. They also work with CSV. You can bring data in from a GPS. You can bring in shapefiles. You can bring in open source layers like WFS. There's lots of things that these tools will run against, right? And you can add that data to your map. You can bring the data in, bring in the different layers. If you know you're going to be doing analysis that compares two layers, go through the process of adding those data to the map, and we covered a lot of that last week. Then analyze the data, actually run the tool. look at the which tool that you want to use based on the question that you got. We'll show you where to find the help as to pick that right tool. Once you've got the tool in mind that you need to use, well, you're going to have to go through and populate some parameters, which layer, which field, what distance, what time, all of these sorts of things. They vary from tool to tool. Specify those, and off you go. Then you will see the results of your analysis. Now, depending on the analysis you do, the results could be a polygon, they could be a table, they could be dots, they could be highlights, they could be hot heat maps. Who knows, right? But once you'll see the results. Now, you may not get the results you expect first time. There is some trial and error. That's why there is an ability inside of ArcGIS to rerun analysis, change some parameters, and rerun that analysis again. So at this point, as we get ready to do some of our demonstrations here, I want to do our first audience participation of the day. I thought it was really great, the amount of participation you guys did last week. So since we're going to be using some data here today, and Samaya's going to show you where she got some of her data, a lot of people had questions last week about where you get the data. A lot of you asked me where we got that Winnipeg data and the data for the Winnipeg recreation centers. It all came from the City of Winnipeg's open data site. So what I'd like to ask each of you is to take this link here or click on that QR code, just like we did last week. And while we're talking through some of the next things, what I'd like you to do is tell us what data sources you are available, you know of, that you use on a regular basis. And there's an other option there. If we're missing some or you've got something else that you know of, let us know and we'll share all the results with you guys during today's presentation. All right, I'm going to set up Samaya right now to start showing us these tools. First thing I want to do is make sure we understand where these tools are located. We are going to be going through a number of toolboxes today inside the GIS. All the tools are organized in different toolboxes. So, and there's lots of information available to you. You'll notice on the screenshot that I've got here, every single tool and every single toolbox has got that little blue eye information icon on it. Click on that icon and you will get a little pop-up that tells you not only what this tool does, but also gives you some sample and some ideas of different scenarios in which you might consider using those tools. The first toolbox we want to talk about today is kind of one of the bread and butter ones. It's the Manage Data toolbox. This gives us some analysis tools that helps us further prepare and refine our data. It allows us to do things like dissolving boundaries. If we've got a lot of neighborhoods and we just want to dissolve down to a smaller number of larger polygons, we can dissolve down that data. We can extract data. We can do exotic stuff like generate grids, what are called tessellations. And I know some of this are GIS geek terms, but I think you'll see as you go through this what some of these things are. You can merge layers together. You can overlay layers to create new layers. So you can take your ward boundaries and your census boundaries, and you can sort of cookie cut them together to create new polygons that share the attributes of both of the original data sets. So it's kind of like taking two cookie cutter things and sort of mushing them together in the dough, and you get new patterns and things like that. Now, we're not going to go through all of these tools today because there are literally dozens of tools. So we're going to go through a couple of them from the data management toolbox. We're also going to look at a couple of tools from the summarized data toolbox. Things like aggregating points. How many recreation centers do we have in each neighborhood cluster? How do you figure that out? Well, that's one thing that aggregate will allow you to do. How do you take data from this table and join it to this set of polygons? How do you summarize the data? Geez, how many around this hospital, how many recreation centers are there? How do I count up, and summarize the number of hospitals in the neighborhood? How do I look at the dispersion of points that I may see? All kinds of different tools. So without further ado, I'm going to stop talking at this point. I am going to turn things over to Samaya, who's going to look at the first couple of tools out of the first two toolboxes. Let's say that quickly as we go through this. So with that, Samaya, I don't know if you can take the ball from me or I can just maybe I'll just drop it on you there.
I think you must pass it.
I have passed you the ball.
Thank you very much. Okay, so just like last time, we have a bunch of stuff to cover, so I am going to get right to it. So just a quick refresher. I have logged on into my ArcGIS Online account. I'm at my home page, and we are going to visit our content page. So from here again, you have access to everything you have made. And I want to bring up our ever so loved Winnipeg neighborhoods data set. So let's go ahead and take a look at this item page and get a sense of what is happening with this data. So here you can see that there are 237 neighborhoods, and the attributes and the fields that we have is we have a neighborhood ID, we've got that neighborhood name, but we also have this cluster ID and a cluster name. And we have our number of diabetes cases happening in each neighborhood. So what we want to do is we want to take all these 237 neighborhoods, and we want to roll those up into neighborhood clusters to get that information at a different level. So here I have a map. There has been nothing added to it. So let's do a refresh of how to add some layers. So I am going to search for that same Winnipeg neighborhoods with cluster ID, and it's within my content, and I can go ahead and add that from there. Okay, so again, we find that same data, and now we can start exploring our managed data tool set. So from here, I can perform an analysis, take a look at what's in my managed data toolbox. And what we're going to be using is the dissolve boundaries tool. So what this is going to do is we're going to be using our cluster ID and our cluster name, because here we can see that some neighborhoods share those same cluster, and we're going to pretty much group those together and dissolve them into one much larger polygon or boundary. So we're going to select our layer or our data set, and that's what we're looking at right over here. We can choose our dissolve method. So the first option of areas that overlap or are adjacent is going to use spatial variables of your data set. But what we want to use are our actual attributes. So I'm going to select areas with the same field value. And I'm going to select that cluster ID and those cluster name fields. So then you also have an option to create a multi-part feature. And all that means is that if two clusters are spatially far away, they're still going to be represented as one record. So I'll keep that checked on. Next, we have an option to add a statistic. So here you can see we have those diabetes case numbers by each neighborhood. So what I want to do is I want to sum up those diabetes cases. So once we roll up that data, I get the total number of diabetes cases within that neighborhood cluster. So we can select that field and select that statistic. There are also other statistics that we can choose from, and it's very dependent on what your data is. So now we're going to create an output. I will save my results, and Here, Chris mentioned credits. So something while you are running a tool, a really handy link is the show credits option right here, which tells you exactly how many credits are going to be used for your analysis. And that works really well for, budgeting, as Chris mentioned. So I am going to go ahead and run that analysis. So right now, while that is running, any cluster ID or cluster name that is similar that is the same in any neighborhood is now being combined together. And those diabetes cases, those are also being added together. So we're getting more information at that neighborhood cluster level. Okay, so now let's take a look at what our dissolved layer looks like. So here now you can see that all those little neighborhoods have been combined into larger polygons or larger boundaries, and in this case, clusters. And if we check out the table, you're going to be able to see that same cluster ID, the cluster name, and now you also get a count of how many neighborhoods there are within that cluster through this analysis. Our next field is showing the sum of those diabetes cases, and you also get a total area in square kilometers. Okay, cool. So now we were able to transform this data. But I do have this neighborhood clusters table that has some more information, such as population data and average income data that I want to combine with this data set. So I'm going to go ahead and search for my table. And here you're able to see that this is, through this icon, that this is a table. So there is no spatial component to it. But I am still able to conduct analyses and use it in during my analysis in my map. So now let's take a look at what our clusters table looks like. Okay, so just like our other data set, we have the cluster ID, that cluster name, but we also have these extra variables that I want to now combine and include into this polygon, this cluster, neighborhood cluster polygon. So let me show you how to do that through the Summarize Data toolbox. So if we go through our analysis, we have an option here to join features, and it's exactly pretty much how it sounds. We are going to be taking a table and we are going to be joining those extra fields and columns to our polygon data set. So let's see what our inputs may be. So first, I'm going to choose my target layer, and that is going to be that dissolved Winnipeg neighborhoods that we created. My target layer is going to be my neighborhood clusters table. And now I have different ways of creating that join. So again, I could do it if there was a spatial relationship, but since I am adding a table, you can see that that's grayed out. So that's not an option. But let's say I did have the same boundaries with these fields, then I would be able to use this option. But since we are using that table, we are going to select some fields to match. And we're going to use those same fields. We're going to map them out. So cluster ID, to my tables cluster ID, and then the cluster name from my polygon to my cluster name in my table. Now there are different join options. Throughout all of these demos, you're going to see that I click this little information button throughout all my tools. These are very, very handy, and they're very descriptive in exactly what each parameter needs and what options you have to explore. So since I know that I'm only going to have one neighborhood cluster, I am going to do a join 1 to 1. And then finally, I am going to just give my results name, and we can name that the complete Winnipeg neighborhood clusters for part 2. And now let's run that analysis. So the first dissolve analysis I showed you was pretty quick to do so. A join is pretty quick to do so also. And again, it's very dependent on how many records you have. So how many features you actually have. So here you can see that we have 23 features in our enriched neighborhoods. Okay, so now that that is done, let's take a look at what our table looks like. Okay, so we have that information that we had from before from our dissolve tool that we used. And now you can see we have those additional fields that we brought in from that table. So really these tools are all about creating a complete data set as detailed as you want it. Okay, so now let's bring in some of our Winnipeg recreational centers that we had brought in part 1. I'll do a quick search. And here we have the same one that we had brought in from our Excel table. And now what we want to do is we want to see which facilities have those fitness components to them. But before we do that, let's symbolize our neighborhood clusters by using that the diabetes information. So I'm going to change my style, and the attribute I want to show is going to be that sum of the diabetes cases. And so here we just have the general numbers, but if I go within my options, I can divide that by the 2016 total population and get that prevalence. So now that I have that information on a cluster level, I'm going to go ahead and filter my recreational data set just to say that, yes, there is a fitness or a leisure center in that recreation center. So let's apply that filter. Okay, so the next tool I want us to look at is actually in the Summarize Data toolset. So next, what we want to do is we want to visualize how many recreation centers with a fitness component are in each neighborhood cluster. And for that, we are going to aggregate the points. So simply, it's just going to do a count of how many points there are in each cluster and help us visualize that to see if there are any patterns that we can notice. So here, since it's a aggregate points tool, you'll notice that it's limited to only point data that I have. So that'll be my recreational centers. Here you can see how I can aggregate that data. So my first option is choosing those polygons and so those neighborhood clusters. But if I didn't have a polygon or a boundary layer, or let's say I wanted a different way of aggregating the areas, I have the options to configure and create square bins and set what those measurements can be for the area it will cover. And I can create a grid to break my area by. Just like square bins, we can also create hexagon bins. But since I am going to stick with my clusters because I want to know how many fitness centers are in each cluster, I am going to select my polygon and keep that layer. So next you have the option of adding statistics. We'll leave that alone for now. And you can also choose you can also choose a field to group this information by. So if we wanted, we can group it by if there's an indoor pool or not, and it will break that down by the yes and the no, and we can add extra fields to see what the minority is and what the majority value is. There's also an option to add percentages. So these options are going to create extra columns or fields in that data set that you are going to output from here. So I have already created this output. I'm not going to run it now, but I just want to show you what it looks like. So I'm just going to move that to the top. I will turn off my cluster or my points for my recreational centers. And now we're able to see that aggregated data. And if we take a look at that table, you can see the count of the points in each neighborhood cluster. We can even show the legend, and now you can see where there is two greater than or equal to two recreational facilities with those fitness components. So now maybe we can take a look, see if there is any more information we can gather through this analysis. With that, that completes our first two toolboxes. So I am going to stop sharing my screen and I am going to pass the presenter back to Chris.
Great. Thank you very much, Samaya. I will reshare my screen so everyone can see it. So that was great. So, I mean, I know a lot of information. There's some of these tools have got a lot of options and a lot of parameters, but we wanted to show you the power that's here, the kinds of things that you could do. We combined some things. I mean, we did the aggregation to count out how many fitness centers you have with a how many recreation centers with a fitness component. You could also aggregate just all fitness centers as well. There's a lot of interesting things that you can do. Now, for those of you who want to type down this link, and I think Mingzi is going to share this link in the chat window here. Let's take a look at the results of the question that we asked. If you recall that last week we asked you where you were from, and we asked you some other questions like how familiar are you with geographic information systems and what other systems are you using, and this was very interesting for us. We also asked you some of the things that you were going to use, and this was great information, and we're sharing this stuff with you. But a few moments ago, a couple minutes ago, I asked you another question. What data sets are you using? And this is really interesting. The vast majority of you using your own organization's health data, which is really, really, that's what we expected. And a lot of you are using open government data, like Samaya and I are using. Some of you are using open non-government data, and a small number are using paid sources of information. Really, I think there's an opportunity here for you in GIS to start look through the enrichment that we showed last week, and we're going to show again today if we have time, to start leveraging some of this non-government data. I think it's very interesting to analyze your own data and see the patterns, but GIS is even more powerful when you combine your organization's data with other government sources, with other paid sources, and you really start to get a really deep understanding as to what is going on with the information. So this is great stuff. Thank you very much for sharing. Okay, let's move on to some of the other toolboxes here. The next toolbox we want to show you is the find location tools. Now we're into some of the really powerful spatial analysis things. The first two tools in the find locations toolbox, the find existing locations and drive locations, that's really kind of a spatial query. Most of you are probably familiar with writing a query in SQL against a database. Think of these tools as kind of a spatial spatial SQL. You can still do the kind of standard things. Show me all of the neighborhoods where the case count is greater than some threshold, but you could also do spatial queries as well. Show me all the neighborhoods that intersect, my ward boundaries, or show me all, derive a new set of another example, derive a new set of fitness centers that are within a 20-minute walk of a neighborhood cluster that has a diabetes case rate over a certain threshold. So you can really start to dive into and combine attribute queries with spatial queries as well. Find centroids gives you points that fall within polygon areas, so you can do other kinds of analysis. Finding similar locations looks at patterns across all your different attributes and says things like, hey, this neighborhood has very similar characteristics to this neighborhood, and so on. And choosing the best facilities is also really good. You can look at, okay, given this set of neighborhoods, what's the logical hospital for the people that live in that neighborhood to go to, given walk times, transit times, and so on and so forth. I'm clicking the wrong button and going the wrong direction here on my slides. There are some other things. Honestly, these next three are just for reference. I'm not sure that there'd be a lot of applicability of a view shed or downstream tracing in public health. If you were doing some drinking water analysis, boil water alerts, and those sorts of things, there are tools here that allow you to create watersheds and do downstream traces through the stream networks that we provide you. You don't even have to provide your own stream networks. By the way, these set of three tools don't use any credits, because they don't rely on any third-party data sets to perform. The other thing we want to talk about quickly before I hand things back over to Samaya while she gets ready is the Analyze Patterns toolbox. This allows you to do things like calculate density and find hotspots. Samaya last week made a simple map where she does a very simple sort of visual heat map. But what if you wanted to create a heat map that persisted and that actually quantified each of the cells? That's what you can do with these find hotspots and interpolate points data sets. Find outliers is interesting. It looks at the statistics and the clustering of phenomena, and it says, are there certain areas, certain neighborhoods that, given everything around it, should have good accessibility to something like grocery stores, but for some unknown reason does not. You can dive in and find these kind of outliers. Again, these things are far more interesting to look at than they are to talk about. So Samaya, if you're ready, I will turn things back over to you. I'll give you back the ball, and we can go ahead and do the next presentation. So I will, oh, my window is hiding on me. I will give you back the presentation ball, Samaya. There you go.
Thank you very much. I will share my screen. And now we can start taking a look at our next map and our next set of tools. Okay, so here we are again looking at our wonderful Winnipeg neighborhood boundaries. I've already opened up the table so we can see what is in here. So, we've got our neighborhood IDs, our diabetes cases, and we also have some total population and some of those extra variables that we have joined with our data set. So the first tool I want to look at is going to be in our Find Locations toolbox, and it's going to be called Find Centroids. So something that you should know is some analyses can only be done with point data and not line or polygon or boundary data. So this tool comes very handy. So within Find Locations, we have a tool known as Find Centroids. And this is going to do exactly what it's saying. It is going to put a dot in the middle of your boundary to create a center point. So let's go ahead and run that tool. My layer input is going to be this in Winnipeg boundaries. I want it at the true centroid, and now I'm just going to give it a name, part 2, and we're going to run that analysis. So while this tool is creating an output with points in the middle of all our neighborhoods, I'm going to go ahead and I'm going to bring in some Canadian Community Hospital data. And this data is going to be from not in my organization or my own content, but we're going to reach to ArcGIS Online. And as I mentioned before, any information that is available through ArcGIS Online is shared with everyone. So I'm going to do a search for the Canadian Community Hospitals. Here you can see it pops up, and we can get some more information about where this data is coming from and if we can use it. So here we can see that it's from the Canadian Institute for Health Information, and it is current as of May 2020. Okay, perfect. I am going to add that to the map, and you can see now we have an output of all these points for our neighborhood centroids. So just for a better visualization, I'm going to change the style of my points, go into the symbology settings, and simply just change the fill to maybe a nice orange. So now we can see where those hospitals are, and we can see where those neighborhood points are. Okay, so the next tool is a very, very cool one. And this one, again, is in our Find Locations toolbox. And we are going to be using the Choose Best Facilities. So what we want to do is we want to assign each neighborhood to its closest hospital so we can get a sense of how many people are going to that hospital potentially, and how many people that hospital caters to. So let's go ahead and choose our best facilities tool. You're going to see that there are a bunch of options. So just quickly going through the options, we have minimize travel. This is very helpful for if you want to locate facilities for the overall travel time. So this is useful, for example, to select a venue for a conference in a way that minimizes travel time for all attendees. So we can have some potential candidates for where the conference venue can actually be, and that will give us the best location to minimize that travel. Next, we have maximize coverage. And this shows you where demand is not being met and where additional facilities may be needed. So if that's your use case, then this is a great tool to use. Next, we have maximize coverage with capacity. And in this case, we want to maximize the amount of demand being covered by the facilities. But we want to identify if the facility has a certain capacity. And once that certain capacity is met, then we extend to our next available facility. So this one right here cover a percentage of demand that is best used when people have a choice of which facility to visit. And it's just always generally assumed that they will visit the closest facility. But for our example, we want to allocate to existing facilities. So we don't want to locate any new facilities. All we want to do is assign the demand to our existing hospitals. So take those neighborhood points and assign them to the closest hospitals. So let's take a look at those inputs. Okay, so first we have our measure. This is super cool because you can actually set whether you want a driving time or a driving distance. And this goes for trucking, walking, and rural driving times. So this actually uses our network and incorporates that into this analysis. You also have the option of using traffic data and actually setting, when, what day and what time of day. So we won't be using that right now, but I do want to show you the availability. So here through this map, Canada is actually, we have predictive traffic. So we have comprehensive street data with historical live and predictive traffic information available. So you can actually use that from our services to include that in your analysis. So next we have the travel direction. Well, we want our demand to this facility. So we want from those neighborhood points to the hospital itself. So now we can identify our demand layer, and that is going to be our centroids, so our neighborhood points. And the amount of demand at each location, you can have a constant, but we're actually going to use our 2016 total population from each neighborhood as a demand to that hospital. Next, we can also have a maximum travel range. So we can have a constant and you can set what those minutes can be. You can have a field if that column is available in your data. But for just simplicity purposes, we're going to choose an unlimited maximum travel range. So we should have each points that have that population data connected to a hospital. So next, we're going to take a look at our required facilities layer, and that is going to be our hospitals. You also have the option of configuring if you want, if your hospital has a capacity. So, you can have a constant capacity or you can have a field. So if we wanted, we could have this total beds option. But again, for simplicity's sake and for visualization, because we want to show you what the final result looks like, we're just going to say the capacity for these hospitals is unlimited. So this tool takes a little bit to run. So I've already processed this information, and I want to show you what the output looks like. So your results come out as this cool spider diagram. And with the tool, the output, you get 3 different layers. So first of all, you get your assigned facilities, and you can see those are the diamonds in the middle, which represent those hospitals. We can take a look at what the data set has. And here you're able to see how many neighborhoods that facility is catering to, and also the population that is dependent on that hospital. You also get some cool information of total travel time for all of the neighborhoods. And also we have that original hospital data that was included in our hospital data set. So that also gets joined into this assigned facilities output. Okay, so next you also have your assigned facilities for your neighborhood centroid. So this is the allocated demand locations, and that is going to be our neighborhood centroid points. So let's take a look at what is in that data table. So here our allocated demand is going to be that population. And as we go through, you'll also notice this assigned facility ID field that pops up. Now, it's also very easy to sort your information how you want to see your table. So I'm going to sort my assigned facility IDs by ascending. So here you can see we have some blanks. And all those blanks, these red dots, and what those red dots mean are these neighborhood points don't have a population, and so they were left out of the final spider diagram. So they're not connected to a hospital in this case. But as we scroll down, we can start selecting each of our neighborhoods, and you'll see through the selection, it will keep changing as I select which neighborhood is assigned where to which facility. And finally, we have these lines. So let's take a look at what data is in these lines. And I feel like the lines provide a lot of important information, such as the total travel time and the total travel distance necessary to get from that neighborhood central point to the hospital itself. And again, there's that information of having the assigned facility ID. So this is a really cool way to kind of see what information you have, what your demand points are, what your facilities are, and just gather more information through making these connections from the demand points to the facilities. Okay, so I want to move on to our next toolbox. And in order to do so, I want to introduce a new data set. So here again, we are looking at the city of Winnipeg, but the boundaries and our polygons are at the DA level, and that is the dissemination area level. Within this information, if I open up my table, you're going to see I have that individual ID, I have the dissemination area population, but I also have this information here that we haven't seen before. And this is from StatsCan Proximity Measures database. So this is the proximity measure for grocery stores. Now let's take a closer look at what the data set actually is and where it comes from. Okay, so here we're taking a look at the StatsCan website explaining what those proximity measures database is. Also, right now, Mingzi is going to be pasting in the link to this site. So if you want to explore this data set a little bit more, you can do so. So that will be in the chat and available for everyone. So the proximity measures database is from StatsCan and Canada Mortgage and Housing Corporation, and it is at the dissemination block level. So these proximity measures are based on a model that accounts for the distance between a reference dissemination block and all the dissemination blocks in which a service is located. So here we can see that there are multiple services that are available in this data set, like employment, grocery stores, pharmacies, etc. So something you need to know about the value itself is it's on a scale from 0 to 1. And if we look at the proximity to grocery stores description, it simply means that if we do have a low score, so closer to 0, there are not a lot of grocery options within a 1 kilometer walking distance. And this measure is derived from the total revenue of NAICS 4451. And NAICS is just the North American Industry Classification System. And if we Google 4451, you'll see that that is the code for grocery stores. Okay, so what we want to do is we want to analyze these patterns and take a closer look at the dissemination areas with those grocery proximity measures and see what we can find. So I'm going to change the style, and the attribute I will be showing is going to be that prox IDX grocery. So here we're now able to see where those higher rates of where the proximity measure is higher, so where there's more access to grocery stores, and then where it is lower. So as you saw when I was going down through this, I actually have all this information available in my data set. But all I've done is I've just hidden all that information. So if I wanted, I can do a deep dive into proximity to health or education. So all those options are available from this StatsCan data set. Okay, so we did a simple visualization, and we're able to see, okay, you know, there is greater proximity in the downtown area, kind of expected more people, more locations, but let's take a deeper look into this. So I am going to go into performing an analysis, and I want to use in my Analyze Patterns toolkit the Find Outliers toolset. And what this tool does is it shows any statistically significant clusters and spatial outliers present in the data. So in terms of using this grocery proximity measure, I want to use this tool to find which dissemination areas maybe have an unexpected grocery proximity measure that is different and maybe an outlier, and I want to investigate that. So let's take a look at our information. So we have selected our layer at the DA level, and here I'm going to select that proximity measure for my groceries. There they are. I have the option to divide, but I'm going to leave that alone. Next, I also have the option to optimize, so either for speed or precision. If I try to find out some extra information, it's going to tell me what methodology the tool is using to determine the spatial patterns that are going to be our output. So dependent on what I want, I can move that around. I can give it an output name. Now, I'm not going to run that now because I know that Chris has already run this tool and has made it available for me. So I'm actually just going to go in and find that outliers grocery information. And if we click on getting some more details, the tool itself does a really good job of talking about those methodologies, talking about the analysis, what the output actually looks like, and giving you some really good information that you can use for your analysis or further exploration. So let's add this data to our map. I'll turn off my DA levels. And just through our symbology, I'm going to make it less transparent so it's a little bit clearer to see. So let's expand and see what is in our legend. So now we're able to see what areas are not statistically significant from what is around, but we have some information about some other areas. So for example, we have anything that's pink is a high cluster. And how I like to interpret this is the first indicator, whether high or low, is what is in your data. So that is going to be a high or low index. And the second indicator, whether high or low, is what is expected based on those surrounding areas. So from here, we can see where those outliers may be. So for example, again, high proximity measure and high expectation. And so in our downtown area, we see that. And then anything that is red it's got a high proximity to grocery stores, but it is expected to be statistically low. So these areas may be, grocery stores in the suburbs. And now, but what we want to concentrate on is this low-high outlier. So here we're seeing that there is a low proximity measure, but we should be expecting a high proximity measure. So maybe we can classify these as potential food deserts. So the access to the grocery stores in these areas is low despite being surrounded by areas that have good access. Okay, so that is what I wanted to show for our next two toolboxes, find locations and analyze patterns. I am going to now stop sharing my screen and turn things over to Chris.
Great. Thank you, Samaya. So, again, lots of stuff there. I think that where you really start to see the power is in looking at that location, and that the proximity data, that index data from StatsCan, really lends itself well to this organization. And what you need to remember here is that those statistically significant outliers, their significance isn't just calculated based on the index itself. It's looking at the surrounding DAs. It's basically saying that this dissemination area, this neighborhood, this block, whatever it is, seems to have a low index or low accessibility to grocery stores, to pharmacies, to hospitals, whatever. But all the surrounding ones seem to have a high index. And that tells you that something's going on there, and you can go in and explore that. Why does this area get a low index when the ones around it don't? Sure, you could just sort of look for similar rows and columns in an Excel spreadsheet, but you're not taking in that neighboring geography. You're not using that proximity. You're not using Tobler's first law of geography. Basically, in that scenario, what we're seeing there with those outliers is we are seeing neighborhoods that, for some reason, violate that first law of geography. They're near something else, but for some reason, they're not like it. And we need to go in and analyze that. And that's really the power of geography and GIS. Okay, last two toolboxes we've got. We're looking at the clock here. We got a few minutes left. I think we're fine. What we want to do is just take a look at some of the other things. Now, one tool we won't show you today because we took a look at it last week is the data enrichment toolbox. And that's kind of like a combination of a join and a spatial aggregation all brought into one. You pass a geometry, a neighborhood polygon, a view shed, travel distance, and it gives you back sort of a calculated or an estimated set of variables that you choose from the data browser. And we went through this in quite some detail last week. But there are some other proximity tools that are kind of interesting. Buffers are straight on crow fly distance areas around something. So if you were to take a dot, put it on the ground, and say, all right, 1 kilometer in any direction as the crow flies, you get a circle. If you take a line and say 1 kilometer in any direction, you sort of get a sausage-shaped polygon that follows the line. Drive time analysis can be thought of as generating buffers, but based on network distance, based on the things Samaya showed us. Drive time, drive distance, walk time, walk distance. Again, things like plan nearest, plan routes, and connect origins and destinations. These are all things that you would want to do if you had some logistics problems. Case in point, say you had a set of warehouses where vaccines are stored, and you've got a set of clinics where you're going to be jabbing people in the arm. What's the optimal route for the vehicles that you've got with their refrigeration systems to get those vials of the vaccine from the warehouses to the vaccine centers within the time windows that they need? And that's what the Plan Routes tool is all about. It's a very complicated tool. We spent an hour and a half just looking at that ourselves. So somebody will quickly show it to you, but you can sort of see where you can get from some of these things. So Samaya, with the couple minutes that we've got left, let's pick a handful of tools, maybe just some of the distance stuff, and talk a little bit about it, and then we'll come back in about 5 minutes just to wrap things up. So what I'll do is I'll give you back the presentation there. I'll make Samaya the presenter again, and I'll hand it over to you.
Perfect. Thank you very much. And let's get started. Okay, so here what we are looking at is just our Winnipeg recreational centers. And again, we have filtered that for our fitness leisure center equaling yes. So all of these recreational centers have a fitness component to them. So what we want to do here is we want to find out how accessible the fitness centers are and what populations they may cater to. So we can do that by using the Create Drive Times Areas tool, and that is accessible through our Use Proximity toolbox. So I know it says Create Drive Time Areas, but just how we had the options earlier for our Choose Best Facility tool, you also have options for drive time or walking or whatever you may need it to be. And again, since this is a point layer, it's going to limit what you can select to only point information. So what we want to do in this situation is we want to figure out what areas have access in a 20-minute walking time to these recreational facilities. So I'll select that. I can have an option to put, multiple areas if I want multiple records. So if I wanted, I could have a 5-minute drive time and a 10-minute drive time, but we'll stick with 20 minutes. Again, you have the option of selecting a day or a time. And if I have the information, I can also select barrier layers. So for example, let's say I had point barriers with a bunch of fallen trees and people can't get past these fallen trees. Well, this is where I would put that and that would account for that. But maybe a more usable example would be line barriers. So let's say we have some road closures. We can use that information and put that into our line barriers. So we have no barriers for now. We want to have our traveler direction towards the facility. And now you have these options of what your output can look like and what you want your areas to look like. So first of all, you can have an overlap of your boundaries. So we know that a 20 minutes walk time around this recreational facility is most likely going to overlap with this one, but we want those individual polygons for each recreational center. Next, you have the option to dissolve. And in that situation, it would take anything that is overlapping and it would merge it into one polygon. And then finally, we can have the option to just create a split. And it is useful if you want to see which areas are within a given time or distance of an input. So I have already ran these results. And this is what they end up looking like. So here we can start selecting, and here you'll notice, some of that overlap that we were talking about. So let's take a quick look at what that data looks like. So here we've got some information about which facility it is attached to, that travel time. We get some extra information about the square kilometers it covers. We can zoom in and really see even to what extent that 20-minute walk time covers. So some really interesting and useful information. So what I also want to do is I want to be able to add some more information to this data set so I know which populations are in this area, who is living here, who has access. And we did take a look at the enrichment tool last time, but just a quick refresher. Within the data enrichment toolbox, we can open up our enricher tool, and through the data browser, we can select population, so 2020 population. And what I've done is I've selected the 2020 population. We can even select a projection of what the 2030 total population may be looking like. And we can even bring in that 2016 identification of Aboriginal identity. Get all those variables, and now we can run it to these boundaries and these extents around these the recreational centers themselves, and get information just for that area. So I again have run that, and we can take a look at what that looks like. So I have that information from my layer before, that facility information. But again, I get these extra fields telling me how much population is there in 2020, how much population is projected in 2030, and also the number of people who identify themselves as Aboriginal. Now, what I actually did was I quickly did a visualization to show the percentage of the Aboriginal population with access to fitness facilities. So what this is doing is it is taking into account how many people within the area identify themselves as Aboriginal, and then dividing that by the total Aboriginal population in Winnipeg. And here we can see that the access to these facilities by people who are Aboriginal is pretty much 4%. So there's maximum about 4%. So there's not a lot of access for people to have. And, you can go in, do some more information, and really analyze your data and try to figure out any correlations that you feel you can get from your analysis. And with that, Chris, I am done my demos for today, and I am going to throw it back to you.
Great. Thank you very much, Samaya. That was fantastic. So with a couple minutes we've got left, let me just go back to our slides here. So we just want to wrap up here. I'm going to leave this screen up for a few moments. We're not going to show you the results of this questionnaire. We do have one more survey we'd like you to take today, so make note of this. Mingzi, who's been doing a great job, by the way, sharing the links all day today. Thank you very much. Mingzi will share this link or use the QR code. Really, just tell us what you think the potential of spatial analysis is in some of these things that you see in your organization, and then we'll cover those. We'll cover those next week. So I'll leave that up for just a few more seconds. What I'd also like to do is turn the mic on. Betsy, I'm not sure if you've been able to join us yet or not. I got a note here that you wanted to just say a quick hello here at the end, so I'll turn the microphone over to you. Hi, Betsy.
Hi, Chris. Hi, Samaya. Nice to see you both. And yes, apologies. We ran into some tech issues, didn't we? But so glad that's been sorted out. So I want to just thank you both and thank Esri on behalf of CHIMA and the Canadian College of Health Information Management for developing and delivering today's webinar as part of the Using GIS from Data Gathering to Storytelling three-part series. It was an extremely informative webinar today, so powerful to see how data can be presented visually through GIS and the story it tells us. Just a reminder for CHIMA professional members who are on the webinar today, this three-part series is worth a total of 4.5 continuing professional education credits. So once you've completed all of the sessions, please submit an entry on your CPE record at eachima.ca. And thank you again, and back to you, Chris.
Great, great, Betsy. Thank you very much. And listen, it has been our pleasure. Okay, last but not least, I'm going to leave things up here. Just again, a quick review. workshop 1 done, workshop 2 done. Remember, next week we've got on February 3rd, we'll be looking at some of the sort of, we're gonna broaden the ecosystem a little bit and look at some other applications, things, maps for Office, creating dashboards, and publishing. Publishing the stories. So a couple of people were asking about the surveys and where they can get the videos. We created a web reference here, esri.ca/chima. There'll be some information there for you to go and check that out. Without further ado, with the few minutes we've got left, we'll open things up to answering some of the questions that have come in online. There's about 4 minutes left. I understand people need to drop off. Really appreciate your time today. On behalf of myself and Samaya, thank you very much. Thank you again, Betsy, thank you very much for the opportunity. Mingzi, in the background, we've not seen you, but we've all heard from you. Great job today sharing those links, really appreciate it. And with that, we'll leave things up. If any questions come in, we'll stay live for a while, but everyone's welcome to leave or send us some questions through the chat. So thank you very much, everyone. This sort of concludes the formal stuff, and we'll take a look at the questions. All right. Now I just got to go over here because I've shared. I got to turn on the chat, turn on my questions. Take a look at some of this. All right. I see that most of the questions that come in have been about, thank you for some of the compliments here. No specific questions, a lot of them about the recordings. A lot of people are asking about the recordings. We will get the recordings out to everybody. Some follow-up emails. We'll make some links available. So we have recorded all these. We'll get everything out to you guys as soon as we can. Do take a moment before you leave to copy some of the links out of the chat. Maybe save their favorites in your web browser. And once again, we'll put together a document with all of these links that we've shown and make those available to you. So with that, I think, Mingzi, I think we can stop the recording there and just leave things live for a few more minutes. Samaya, thanks very much. Great job.